Now we will see how external bolt can be modeled. So let's go for part number 5 here. Okay, so for this part number 5, which is the external bolt, they have given the front view. So let's go for creating this bolt, external headed bolt in the front view. Okay, so in order to create that, you need to remember that bolt is nothing but it will have threaded part and the head part. Okay, so this threaded part will be having a solid cylindrical portion, while this particular head part will be in the form of hexagon. So therefore what we do now is we are going to create this hexagon first here. So let me show. Okay, so I will go for select. I will click on this create new part here, and then I will go for. So since this is the front view, okay, so what I do is I am going to select the right plane. Okay, and on the right plane I am going to create the sketch. So select the right plane, then click on the sketch option. Then what I do is there is an option here, something called as polygon. So in the sketch command manager tab, okay, so when you click on sketch command tab, okay, so somewhere here you will find option called as, or the command called as polygon. So select that polygon, then okay, so try to select the center of the polygon, then try to draw the which one, polygon, something like this. Okay, so I'm drawing in this orientation. So let me construct like this. So once it is done, you can see you can go for varying the polygon numbers. It is 5, it is 6, like this. Okay, even if you want 4, you can do like this. So you can give okay, how many sides you want in this box. Okay, number of sides required can be entered here. So right now they have mentioned that it is hexagonal headed bolt, so therefore this should have 6 sides here. So I'm going to give the number of sides as 6 here. Okay, and then I will click on OK. But then the question is what should be the distance from ear to ear. Okay, so what should be the distance from ear to ear? So the distance from ear to ear is nothing but, okay, so distance between the corners. Okay, so distance, so if you have learnt in as if you recall what you have learnt in your machine drawing, okay, so we are going to give, we can go for defining the distance between the flat sides here, or distance between the corners. Okay, so and we know that if the rod portion, that is if the thread portion of the bolt, okay, is having diameter of d, then the head portion here should have diameter as 2 times d. Okay, that is the relationship or the proportions to be maintained. So, and that 2 times d is the distance between the corners, okay, of the hexagon. So what I do now is I will select smart dimension, and I will select this particular point and this point, and I'm going to give this value as, so what should be the value? So if the thread portion, that is if this particular rod portion, okay, of the bolt is having 16 mm diameter here, as it is mentioned as M16, then okay, the distance between the corners, okay, should be 2 times how much? 2 times 16. Okay, that is 32. First define that, but still the hexagon is appearing in which one? Blue color. So therefore what I do is I will check what degree of freedom this hexagon is having now. Okay, so if you try to move this one, it cannot be moved, but it can be rotated like this. So because of that, what I do now is I will select this particular point. I am going to select this particular point, and then holding the control key I will select the origin, and then I will bring these two particular these selected points on the same vertical line. Then it will be constrained. Then I will exit from the sketch. Okay, then I am going to the isometric view. So now you can see we have created a hexagon. Then I will go to the features. Then I will go for adding the material within this hexagon. Then I will add the material towards the left side. Okay, so therefore I will reverse the direction here, and what should be the thickness here? So the thickness of the head of the bolt should be 12 mm. So therefore I am going to enter this as 12. Okay, so this is done. So head of the bolt has been created. Then what I do is I am going to create this thread portion. So this thread portion is nothing but it is a solid cylinder of diameter 16 mm and length equal to 41 plus 25. Okay, out of this length 25 mm for 25 mm length of the rod is having external thread, and remaining portion of 41 mm length is not having any thread. It is a plain surface. Okay, so therefore what I do now is I am going to select this back face of this hexagon head, and on that particular face I'm going to create a sketch now. So select sketch by selecting the back face of that head and keep it in left side view. When you keep it in left side view, now I'm going to select circle command, and I'm going to draw one circle here, and this particular circle should have diameter of now 16 mm. Okay, so then you can see the sketch is fully defined. You can come out of the sketch and you can keep it in isometric view. You can see there, okay, you can see that this particular circle has been created on the back face of the head. Okay, so then what I do after by selecting this sketch 2, I will go for adding the material within that circle. Okay, by using extrude option. So select the extrude option. Okay, so now what should be the length to be given? It is 41 plus 25. So therefore here I am going to add this as 41 plus 25. Then click OK. Okay, then fit to the window. So now we can see this is the this is the rod of the bolt. Okay, and this is the head of the bolt, and if you try to keep it in front view, it is going to look like this. So this is exactly same as this, but few things are missing here. That is, we need to make the chamfer here, and we need to show the thread here, and here we have to do the chamfering. Okay, so means the top face of this hexagon head of the bolt should be chamfered, but they have not given what is the chamfering angle. But if you recall the proportions that you have used for creating the square hexagon headed bolt or square headed bolt, the chamfer angle should be 30 degree. Okay, with respect to the vertical line here. So therefore that should be added now. But before to that, let me add the thread here. So in order to add the thread, okay, so what you can do is you can go to insert. Okay, you can go to the annotations, you can go to the cosmetic thread. Okay, then first we have to, so under thread settings, so go for selecting the circular edge from which the thread has to be displayed. So I am going to select this particular circular edge here. So this circular edge will be selected. From this circular edge, I need to display the thread. Okay, for a length of how much? 25 mm. So therefore, I will go for isometric, and it should be how much now? It is M12 thread. So I am going to select it is M16 thread. It is not available there. Okay, here. Okay, M16 thread, you select it. Then up to next. It is not up to next. We will use blend option, and here the length should be how much? 25. So length of thread should be 25 mm. So then click on OK. Okay, now you can see there is a small inner circle appearing here indicating okay, so the cosmetic thread has been inserted, but we are not able to see the graphics of the thread, okay, on the outer surface of the rod. So whenever this happens, go to the SolidWorks option here, click on this. So go to the document properties, go to the detailing, and go and turn on the shaded cosmetic threads. This has been explained several times during the modeling and assembling of the screw jack assembly. Okay, is that clear? So now you can see okay, we can see the thread graphics over the outer surface of the bolt for a length of 25 mm here. Okay, so once it is done, so now you can keep it in front view like this. So okay, so this is the thread length. Okay, we have thread from here to here. Then what we have to do, we have to make a chamfer here. So unless otherwise mentioned, okay, so all fillets and round should be of 3 mm. So but here we don't give 3. Okay, so we are going to restrict ourselves only for 1 mm chamfer. Okay, so what I do is I will go for fillet. Under the fillet I will go to chamfer, and then I will select this particular circular edge, and here the value should be 1 mm, and then click on OK. So now chamfering has been done. If you want, you can keep it in front view. Sorry, you can keep it in front view now, and you can see the chamfering has been made for 1 mm and 1 mm length and 45 degree. Okay, and the thread has been placed. But only thing that we are missing now is which one? We are missing this chamfer on the top face of the hexagon head. Okay, so therefore this chamfer has to be made, but this is a little bit tricky. So what you need to do is if you have time, you can go for doing that chamfering. Otherwise you ignore that chamfering, and you can directly use this itself as the bolt in the examination, because what I am going to explain now you may not be able to understand quickly, and you may waste your time in doing that chamfering. So therefore, so I am going to save this file as part 5, and this is which one? Hexagonal headed hexagonal bolt. Okay, so you can treat this itself as the final model for assembling purpose. Okay, but if you still want to make the chamfering, still if you want to make the chamfer on the top face of the hexagon head here, so then I will explain the procedure now. Okay, again I am telling, if you have time in the examination, then only you go for doing all these final small touch-ups. Okay, otherwise you just go for the without chamfer, also you go for the assembling. Okay. So now let me explain about how to add this chamfer. In order to add this chamfer, first we have to get the chamfer circle. Okay, chamfer circle is that circle, okay, which is going to touch all the 6 sides of this hexagon. So in order to get the chamfer circle, I will select this top face of the hexagon head here. So the top face of the hexagon head will be selected, and then okay, I will go for creating a sketch on that particular face. Then I'm going to keep it in right view. Then what I do is I will select circle command. Okay, and then I will draw one circle. Okay, so that this circle will come as a tangent to all the 6 sides. Okay, you can see now. Okay, so the circle is touching all the 6 sides, but it has not turned into which one? It is not turned into black color, indicating it is not constrained. What is that constraint? We can vary the diameter here. So if I want to restrict the variation of diameter, what I do is I will select this circle, and holding the control key I will select one of the side of this hexagon. Okay, so I will select this one. So arc is selected here, that is circle. Edge one is nothing but this side. Then I am going to make it as tangent. Okay, so I will add the tangent relationship, then click on OK. Now you can see that okay, so we have created a circle on the top face of the hexagon head like that, and this circle will be called as the chamfer circle. This you should remember. Then what we do is, okay, so we will come out of this particular plane. Once that circle is done, you just come out of that plane. Okay, so this particular circle is actually only for, will be used only for construction purpose. Okay, so then what I do is I am going to select the front plane, and you need to remember this particular front plane is passing through, okay, this corner and the opposite corner here. Okay, so therefore we have to select the plane which is passing through the corners. But if you try to select the top plane now, okay, so this particular top plane is not passing through any of the corner of the hexagon head. So therefore this is not useful. Or even if you try to take the right plane, it is not passing through. Okay, it is not passing through the opposite corners. Okay, so only plane that is passing through the opposite corners here is front plane. So select the front plane. Okay, and then what you have to do is you have to click on sketch option, and then you should go for keeping this model in the front view. So once it is kept in front view, now okay, so what you need to remember here is this chamfer is nothing but it will have, we need to cut the material for what shape? Triangle shape here. Okay, so we need to cut the material for triangle shape here. Okay, right angle triangle shape. So therefore what I do now is in this front plane I am going to create one rectangle. So sorry, triangle. Okay, right angle triangle. So right angle triangle has to be constructed like this. So let me construct it from, so exactly from somewhere here I am going to construct one rectangle, sorry, triangle like this, right angle triangle. So you can see now, okay, so a triangle has been created in the front plane. Then what I do is I am going to define the angle between this particular line and this as 30 degrees. So this is from the proportions. Okay, once it is done, next what we have to do is, okay, so come out of the dimensioning, and then you just slightly tilt this model. When you tilt this model, so let me come out of the dimensions. Okay, when you tilt this model, you can see now, okay, so if you click on sketch 3, so what is this sketch 3 now? Sketch 3 is the chamfer circle which is touching all the 6 sides of the hexagon. Okay, so what you need to do now is this particular point, see in the front view actually. So if you try to keep it in front view, so this only this particular line in this triangle is appearing in blue color, means okay, the size of this triangle can be varied like this. Okay, but how to constrain this, that is the question. So how to constrain means, okay, so select the sketch 3, that is the chamfer circle here. Okay, then what I do is, so I will select first I will highlight the sketch 3, then I will go for highlighting this particular point, because this can be moved actually. Okay, so I will select this point and then I will select this circle by holding the control key. So this particular point, okay, on the which one triangle here should come and coincide with this chamfer circle. Okay, so therefore because around this chamfer circle the material should be cut for 30 degree. Okay, that is called as the chamfer chamfering of the bolted. Okay, so therefore this particular point of the triangle should coincide with the circle that we have created here, and within the triangle we have to cut the material, okay, around that circle. So for that I am going to select the point and the circle, then go for making it as piers. Once it is done, okay, so you can see now, okay, so this particular point is on this circle. Once it is done, then okay, what you have to do is again keep it in front view. Okay, so we are going to cut the material within the triangle now. But how to cut the material? We have to cut the material by using revolve option. Okay, so far we used revolve option only for adding the material. But I think this is the first time where we are trying to remove the material using the revolve option. So whenever we want to use the revolve option, we need the center line. So axis line. So select the center line here. Okay, so here you create one center line. Okay, so once it is done, you can see that sketch is fully defined now. Okay, then come out of this sketch plane. Okay, so then what you have to do is by selecting sketch 4 now, go to the features, go to the, instead of going revolved boss, now you have to go to revolved cut here. So use the revolved cut. Okay, you can see now we are trying to cut the material within this triangular profile, which is having an angle of 30 degree, and one of the corner point of the triangle is touching that chamfer circle, which is touching the 6 sides of the hexagon head. Okay, and we are trying to cut the material about this axis now. So then click on OK. So this is how the chamfering will be done for the hexagon head, hexagon bolted. Okay, so then if you want, you can keep this sketch 3, otherwise you can go for hiding this sketch 3, okay, which is the chamfer circle. Then it is going to look like this. So now if you try to keep it in isometric view, so it is going to appear like this. Okay, so in the front view it is going to appear like this. So you can now see here it is 30 degree chamfer is there. Okay, 30 degree chamfer is there. Okay, so then here chamfer is there, thread is placed. Okay, it is hexagon, 3 faces are visible here. Okay, if you try to look this in top view, it is going to look like this. Okay, so and finally this is the isometric view. Okay, so this is how it looks. Okay, is that clear? So then keep it in isometric view. So go for saving this file. Okay, so the file has been saved as part 5 hexagonal bolt. Now same thing has to be done for creating the which one? Nut. So nut will not have this rod portion. Okay, so only thing is it will have the which one? Head portion. So what I will try to do is since here this is again nut with M16, that is nut having inner diameter of 16 mm here. So I will try to save the same file. So I'm going to save this file as part 6 now. Let me try this. Okay, I don't know whether it will work or not. I'm going to save this as a hexagon nut. Then I will save this. Okay, now it has become part 6 and it is hexagon nut. Now in the case of hexagon nut, we will not be having this rod portion. So for that purpose, what I do now is I am going to I will try to delete. Okay, so this particular extruded part, that is this highlighted blue color part, I will try to delete. Let me see what happens. Cosmetic thread will be removed. Yes. Like this. Just a minute. I think when I clicked on deleting of that extruded part, I think okay, so I think it's working now. So you can delete that. So therefore we have left with only the head here. Okay, so once we left with the head, okay, the meaning is that okay, so by making a hole in this head now, okay, that is in this hexagon head, okay, if we try to make a hole in this hexagon head, it will become what? It will become nut. Okay, so therefore what we need to do, but only thing is we need to modify this head thickness here. Okay, means nut thickness should be 14 while the head thickness of the bolt is 12. So where it can be modified, I will tell now. So go to go for let me check it here. Okay, so right click on this boss extrude here, go to edit feature. So instead of 12 now, I am going to give this as 14. That's it. So then click on OK. So that this is how we can go for increasing the which one? We can go for increasing the thickness of the nut. Okay, to 14. So where it has to be done? Right click on the boss extrude and click on this edit feature. There you change this depth of extrusion as 12 to 14. Okay, so then give it OK. So then what we are, so and there is no need to do the chamfering and all because already it has been done. Okay, so then what we need to do, we need to make a hole here. So for making a hole, I will select this face. I will go for sketching here. So I will keep it in right view now. So then what I do is I will select circle command and from the origin I will draw one circle here and it is given that here, okay, what it is a nut of M16. Okay, so therefore it is having M16 metric thread with 16 mm internal diameter. So we are constructing a circle for 16 mm diameter now. Then what I do is the sketch is fully defined now. I will come out of the plane. I will go to the features. I will go to the extrude head cut. Okay, and I will click on through all. So material will be removed from here to here. Okay, so from here to here material will be removed. Give it OK. Is that clear? So therefore you can see that almost nut is formed, but only thing is we are not seeing any graphics on the inner surface here. So here this inner surface of the nut should show what thread graphics. In order to add the thread graphics, so for visualization purpose, I am going to add the cosmetic thread. Go to the insert, go to the annotation, go to the cosmetic thread. Okay, so here first it will ask from which circular edge we have to add the thread. So which circular edge? From this one. Okay, and you can see it has taken automatically M18. We don't have any M16 option, just to go with M18. See, again I am telling this the cosmetic threads are only for visualization purpose, nothing else. Only for appearance purpose these will be used. These are not the exact threads. Okay, on the nut. Okay, is that clear? So if you want to make the exact thread on the inner surface, then you have to create an helix. Then for that helix you have to define a profile, square profile or the V profile. Then for that V profile, by using the sweep option, you should go for cutting the material. So all those things will take time. We will even there is no need to do all that. So just try to provide the cosmetic thread here. Then click it on what? It is blend through all. Okay, so through all up to next I will use, then click on OK. Okay, you can see this is how the nut is going to appear. So let me keep it in front view now. This is the front view. Okay, so this is the front view. Okay, and then only difference now is this face is actually chamfered here, but in this figure it is shown as a left face of the nut is chamfered, but it is immaterial. If you want to really change that, you can go to the back side view here. Then it looks exactly same as this front view. Then what you can do is I think they have not given any other view. I think it is sufficient. Okay, if you want to visualize like this, you can visualize. So this is exactly same as this nut here. Okay, so then I will bring back to isometric view and I will turn on the solid form, then save this as a nut. So this is how easily you can convert the bolt into nut by removing the rod portion of the bolt. Okay, so once it is done, now all the 6 parts, okay, all the 6 parts of the flanged coupling have been modeled. Okay, so therefore we can go for assembling all these parts now, and we can go for getting the final assembled view. Okay, as a final assembled 3-dimensional view can be obtained. Okay, so therefore let me go for creating the assembly file now.